This short video provides guidance on the other roof items that you need to consider when measuring approximate quants. If we look back at my roof model here, you can see that we also need to include for our roof verge and also the eaves detail. So let's look at the verge first. If we look at our model, we can see that I've indicated the verge in red. We need to establish the total linear length of verge. Here we have the model. We can see we have 1, 2, 3, 4 verges. To establish the linear length of the verge, we need to look at section AA. If we go to section AA, we can see that we have the scale, and using our correct scale, we can scale the length of the verge. We scale from the apex here to the end of the trussed rafter here. So we need to scale this linear length to establish the length of one verge and then multiply by the total number of verges in our times in column. Now let's look at the eaves. Our eaves detail I've indicated in blue. Note it runs the total length of the roof. So in terms of our eaves detail, we need to make sure that we allow for the eaves at the front elevation and also at the rear elevation. The length of our eaves we've already established because the length of the eaves will be the same as the roof plan length. The next item to consider is the length of our rainwater downpipes. These aren't shown on the drawing, but we can establish the length of our downpipe from section BB. If we look at this section, I've identified the length of the downpipe on the drawing in red. So it runs from the underside of the gutter down to ground level. Obviously this hasn't been annotated as a separate dimension on the drawing, so we need to piece together the information. So let's have a look at what's been annotated. If we look here, we can see that we've got an annotation of the height from DPC to the top of the composite wall. If we take our scale ruler, we can see that the top of the composite wall lies in line roughly with the top of our gutter. So if we take our annotated height from the top of the composite wall to DPC, we know it's this figure here, and then we need to make an allowance from DPC down to ground level, which is going to be 150. This can also be verified by looking at these figures here. So in our waste column we established the height of the downwater pipe. It's going to be the height from the top of the composite wall to DPC, add the height of DPC above ground level, and then we need to make an adjustment for the overmeasure here. So you need to scale the depth of the guttering there. Once you've established the height of the rainwater pipe, you then measure it as a linear item in the dimension column. On the elevation you won't find the rainwater downpipe shown, so allow one rainwater pipe on the front elevation and one on the rear elevation.